the peace, blessing, and mercy of God be upon you. Today we will start solving computer science paper 4 AL October November 2023 variant 2. In the previous videos we solved variant 1. You can check the channel. This exam have 3 questions. So we'll move through 3 videos. You can find link in description. Open the evidence document, evidence.doc. Make sure that your name, center number, and account number appear on every page of this document. This document must contain your answer to each question. Save this evidence document in your work area as evidence followed by your center number and account number. A class declaration can be used to declare a record. If the programming language used doesn't support arrays, a list can be used instead, which that's what we have to do in Python. One source file is used to answer question 1. The file called stakedata.txt. Number 1. A program stores lowercase letters in 2 stacks. Okay, so we have a lowercase letters in 2 stacks. One stack stores vowels, which are A, E, I, O, and U, and one stack stores consonant letters that are not vowels. Each stack is implemented in one as a one-dimension array. So let's review stack. Stack, which means we have something like this: 2 stacks, one for vowel and one for consonant. Stack use last in, first out algorithm, which means we need to push for insert and pop for delete. And we have a top pointer which point to the first free space to add elements. Okay, so write a program code to declare 2 one-dimension global arrays: stack vowel and stack consonant. Each array needs to store up to 100 letters, so we have the stack will be full if we have 100 letters. The index of the first element of each is 0. If you are writing in Python, include declaration using a commands. Okay, I'll go to Python. Open a new file. And then we can declare this stacks. So stack vowel, which is an array, and for declaration I'll write a command. This is a string of 100 elements. And stack constant, which is an array, and for declaration it is a string of 100 elements. Okay, back to exam. Save your program as question 1 and 23. Okay, we'll go to our code, run, save as, and go to our work area. Name it as question 1 and 23 and save it. Okay, you can take a screenshot for the code and then copy. Go to your evidence, 1AI, Control V, make it behind, and save. Okay, back to exam. The global variable vowel top is a pointer that store the index of the next free space in the stack vowel, and the global variable consonant top is a top pointer to store the index of the next free space on the stack consonant. So we'll need to declare these two pointers. Vowel top and consonant top are both initialized to 0. Data program code to declare and initialize the two variables. If you are writing in Python, include declaration using commands. So you will write a global variable, global vowel top, and this is an integer from 0 to 100 or from 0 to 99, and the other global constant top is an integer, and we need to initialize vowel top to 0 and the constant top to 0. Save. Here we can take a screenshot for this code. Copy, go to your evidence, and in 1A double I control V, make it behind and save. Back to exam. Number B, a procedure push data takes one letter as a parameter. So we have a parameter is a letter. If the parameter is vowel, it is pushed onto stack vowel and the relevant point updated, which means after inserting or pushing the letter, we need to increment the top pointer to point the next free space. If the stack is full, a suitable message is output. So you need to check firstly if the stack is full or not. So if the top pointer in 100, this will be full. Otherwise, we can insert or pushing the new letter. If the parameter of is consonant, it is pushed on the stack consonant, and the relevant pointer update the same thing. If the stack is full, a suitable message is output. You don't need to validate that the parameter is a letter. Write a program code for push data. Okay, we'll go to our code, and we will define the push data procedure. Push data, which will take the letter as a parameter. Okay, and we will use the two global variables. The vowel top and the consonant top. So we need to ask if this letter is a vowel or not. If it is a vowel, we will work with the vowel stack. So if letter contain the first vowel character, which is A, or letter contain E, or letter contain I, or letter contain O or letter contain U. If that, we will go to work with the vowel stack. So we need to check if this vowel stack is full or not. Okay. So if vowel top contain 100, that means is full. So we'll print a message for that, which means vowel stack is full. We cannot add the new element. Okay. Otherwise, so else we need to insert the element and then update the pointer, which is the vowel top. Else, we'll append this letter stack vowel dot append the parameter letter okay, and then increment the vowel top pointer. So vowel top would be assigned as a vowel top +1. Okay. Else, this will be a constant. So else, we'll do the same thing with the constant. So else, if constant top equal 100 or contain 100, so the constant stack is full. We cannot add new elements. Else, we will update the stack constant by updating by appending this letter, and we'll increment the constant top by 1. Okay. Save. Fine. Take a screenshot for the code of pushing data. Copy and go to your evidence, and in 1B, Control V, make it behind. Okay. Save. Back to exam. In I, the stick data.txt stores 100 lowercase letters. The procedure read data, reads each letter from the file, and uses the push data to push each letter onto an appropriate stack. Use appropriate exception handling, which means that we will use try except structure if the file doesn't exist. That's a program code for read data. Okay, we'll go to our code. We'll define read data. Okay. And we'll open the file and store this file, this data into a new variable. So we write try. The new variable will be data file. I'll assign the file. So open file, open the stake data. Yes, it is a capital letter. Data.txt. Okay. And then we need to move each line to the stack. So we'll use this push procedure. So for line in the file data or in the data file, this is the file for line in data file. We will push each line. So push data for this line dot strip. And then we can close the file. So data file after this for data file dot close. Except we don't find the file, so except print file is not exist. Doesn't exist. Okay. Let's save. Okay, take a screenshot for the read data procedure, copy, go to your evidence and Control V, make it behind, save, and back to exam. Number C, the function bob val removes and returns the data at the top of the stack val and update the relevant pointer. So we need to decrement the top pointer to point the first element to the last element inserted, and then delete this element. The function bob consonant remove and return data from the stack consonant and update the relevant pointer. The same thing. If either stack is empty, the string no data must be returned. Write a program code to declare bob vowel and bob consonant. Save your program. Okay, we'll go to our code. Let's make a space here. Okay. Firstly, we'll define the bob vowel. Okay, and we'll use the two global pointers, vowel as consonant. Okay. Now, if vowel top is greater than or equal vowel top -1, greater than or equal 0, which means we have elements we can delete. So vowel top will be decremented. So vowel top will be decremented by assigning vowel top -1. And now we need this element to be returned. So I'll make a variable data to return, and I'll assign this value stack vowel, where the vowel top is assigned. And then we can delete this element. So we can then stack vowel one element -1, and then return the data to return data to return, which is the element we point to. Else, we need to return no data as mentioned in the exam. So else return no data. Okay, we need to do the same procedure for the consonant. So use pop consonant, and we'll use the consonant top. If the consonant top -1 greater than or equals 0, so we'll decrement the constant top by 1. And the data of the state consonant, where the constant top, so we'll delete from the state consonant, -1, and we will return the data to return. Otherwise, that's mean we need to return no data. Okay, fine. Take screenshot for the two procedures. Copy, go to your evidence, and in YC, Control V, make it behind. And save. Okay. Back to exam. 1D. The program first needs to call read data and then prompt the user to input their choice of vowel or constant. Take as an input the user choice. Depending on the user choice, so you need to make this variable choice, call pop vowel or pop consonant, and store the return value. The 3 steps are repeated until 5 letters have been successfully returned and stored. So you need to loop for these procedures 5 times. If either stack is empty at any stage, an appropriate message must be output once 5 letters has been successfully returned and stored their output in on one line. For example, ABYTR. Okay. We'll go to our code, and we will use the top the vowel top and the consonant. Top with 0, and we'll call the read data procedure. Put the letter with empty space at the first. This is the letters which we will collect or concatenate the letters in this variable, and the flag will be false. So we need to do this for 5 times. So for x in range from 0 to 5, okay, we'll put the flag we'll put the flag as a false. Okay, so while flag contain false, okay, we need to prompt it and take the input from the user. So choice will be, I'll assign in the choice variable what the user will be input. So input, and I'll prompt the user vowel or consonant. And we make this selection as a lowercase, so that lower. Okay. This is the choice. Okay, fine. If choice contain vowel, so we'll pop from the vowel. So if it's contain vowel, so data accessed will be assigned by the procedure pop vowel. Okay, and if the pop vowel returned no data, so I'll concatenate the letter. So the letters, if data accessed, so yes, if data accessed is not equal or don't contain no data, okay, then we will concatenate the letters. So letters will assign by letters concatenated with the data access. And we'll make the flag equal true. Okay, else that means there's no vowels more. There's no any more vowels. Else print no vowels to out. Okay, but if the choice is consonant, if choice contains consonant, Then the data accessed will be assigned by the function Bob constant okay, and if data accessed don't contain no data, then letters will be concatenated with this letter. So it will assign with letters concatenated with the data accessed. And the flag will assign to true. Else, so you can make it like an elif. So this will be else the last print no constant left, no constant left or to output. And then we need to print these letters. So print letters. And save. Yes. Have a spelling mistake here. This flag. Okay. This flag. Okay. Save. Fine. Okay. Take screenshot from the main. Copy. Go to your evidence and Control V. Make it behind. Okay. Test your program with the following inputs: vowel, consonant, consonant, vowel, vowel. Take a screenshot to the output. Okay. So we'll go to our code. Run. Test by vowel. Now consonant to output. We need to review our code. Okay, the choice, we need this in a lowercase, so we write this as a vowel, and this will be as a consonant with small letters. Now we can run, save, we write vowel, consonant, consonant, vowel, and vowel. This is the 5 elements, and this is the output. Okay, can take screenshot for the output, copy, back to your evidence, go to your evidence and Control V, make it behind, and that's it, save. Back to exam. The next question will be number 2. We will record this in a separate video. Thanks for watching. See you next video.